So you can see this is the cheat sheet for scikit-learn. What is scikit-learn? Open source Python library that implements range of machine learning, pre-processing, cross-validation, visualization, using unified interface. So this is an example of, so we talk about that. Loading the data, also see NumPy and Pandas. NumPy, you can see NumPy for random numbers. Scikit-learn for pre-processing. You can see what I was explaining, supervised learning and unsupervised learning. For supervised learning, you have linear regression, SVM, there are a lot. You have linear regression, you have random forest, you have, these are models. So you have random forest, you have decision tree, you have XGBoost algorithm, you have Naive Bayes, you have KNN, you have logistic regression. So you have a lot of them. It's just for you to, and what differentiates all these tools is just accuracy. Some are better, don't give you better accuracy than the others. For example, for decision tree and random forest, they are both supervised learning methods, but random forest is more accurate than decision tree. So depending on, so this will help you to decide, okay, which one do I use? Unsupervised learning estimators, model fitting, predictions. So we talk about that. Go to scikit-learn. So evaluate your model, translation metrics, absolute. So these are just, and this is what I've just explained before. You can see a lot of them. These are classification methods. So when I say classifications, we're talking about a 0 or 1, or you get it, yes or no. When what you want to do involves, does this person, will this person win this competition or not? So these are some of the things some of these betting companies use. So you see that a lot of betting companies in South Africa, in US, they are looking for machine learning engineers, and what they really need them is to do these predictions, game engine shows. They want to do predictions so that, you know, to know who wins and all. So all these algorithms here is, they are all classification problems. SCV, Naive Bayes, kernels, K neighbors classifier, SGD classifier, and this is telling you that they are good when your sample, right, the data you want to push to the model is maybe less than 100,000. When the data is, you can see when the data is also for regression problem. These regression problems are the ones I told you about, house price prediction, that gives you different values at each point. So under that one, you have linear regression, you have SGC regression, ridge regression, ensemble regression, a lot of them, right? And then dimensionality reduction as well, DR, randomized PCA. So dimensionality reduction is you use it in feature engineering. So when I say feature engineering, what do I mean? So what I mean by that is, there are times you have, if you see some mad data, I think Michael shared one some times ago, the data has almost 100 columns. Just imagine the data has 100 columns, and you want to use such a data to make prediction. Column A, B, C, D, E, F, G. So the columns is too much. So you can use a method. There are different methods, right? One of them is dimensionality reduction, that helps you to reduce the number of columns to the ones that will give you the answer you are looking for. So you can use that. It is that small column now that you now use to train, because as your number of columns increases, there is a high chances of overfitting or underfitting your model. What do I mean by overfitting? Now you want to measure, you have a fridge and you want to measure how long it takes for water to become block, right? so that anytime you are putting another block there, you can tell anybody that block is going to be that water is going to turn to block in the next 3 hours. Just imagine you now went to test your algorithm with a big pot that is very thick, or with cooler that is very big, and you now put it there. And you now want to test your prediction now on what you've done. This water will become block in 5 hours. You know that cooler or food flask, for example, will take maybe 10 hours before it will turn to block. Abi? Now you now want to test with not just ordinary cup. So that's what we call, like, you are overfitting your model. So in this case now, your fridge is your machine. Your water is the what? Is the data set that you are training, that your machine want to train. You want to train your machine with. Now, the new cup that you are bringing in is your test. So is another data set that you want to test to see if your machine, which is your fridge, has learned from that model. So if you use the wrong data set to train, you call that one overfitting or underfitting. So it's either you are overfitting it so that the machine will not train well. That is in the case of maybe big flat, or underfitting it, and you now went ahead to go and put maybe small cup or something. Or most times, even possibly, maybe you want to now test with a pure water, and also when you were training that data, you tested with a very dirty water that has impurity. So I'm just using that to explain overfitting and underfitting. So dimensionality reduction is a way to help reduce this. So these are methods we can use. And then clustering. So I thought about clustering. This is more of a unsupervised learning, right? Which you see being used in banks and by e-commerce companies. Amazon also uses it. I think Amazon uses K-means. So that, okay, you can see number of categories. This one is closed. This one is closed. Will this one give me the answer? So if this person order for 10 things for shoe, you might want to make sandal, you might want to make this. So something just so this is just machine learning at a glance. So this will help you a lot. So I think this guy should have installed now. So I installed. So questions first before I proceed on what I've taught so far first before we proceed. Questions. Oh, you understand everything? Wow.
Sir, I'm following, sir.
Okay, so I can proceed. Good. So I was using this to illustrate how NumPy works. So majorly, that's how operates with NumPy. Now let's see Pandas. Now Pandas has installed. The same way you install Pandas and you call it alias, this is NumPy. That's the same way you do for Pandas as well. So you say import Pandas. Now, Pandas, you can do a lot of things, right? With Pandas, you can see with Pandas, you can create a data frame. So when we say a data frame, so we'll talk about that. I will create some. So you can create data frames. With Pandas, you can melt. So remember in Power Query, there are times you want to turn rows to column, Abi, and columns to rows. And there was a data set I gave us at a point where in a code you have them separated by comma, and you want to make all those comma become they should become one row that will now pivot. So in Python, what we call that process is what we call melt. So remember in Power Query as well, by Power Query, what you have what you achieve with that pivoting, you now have two columns that have variable and values. I think for Power Query is items and value. So you can also melt. This is melt is another word for on pivot, right? These are things you can also do with it. So you can see melting. Look at the illustration. You are turning 3 rows, then you are turning it into 2 values and item and values, right? So you can also concat. Concatenation is appending in Power Query. So when I want to append this first table over the second table, I will use pdf df1 df2, then it becomes 1. I can also concat, append columns of data frames. You can see. So this one, I'm concating on, I'm concating those. So what this will do is, remember, this is what is common to both. It will bring it out. This one is a new column. It will give it another column. So I don't know if you have appended in Power Query before. If you append 2 tables that don't have the same number of columns. So let's say you appended let me go to, let me see, wait. That to illustrate. So if you have a table that has A and B, another one has B and C, you try that in Power Query. What you get is, and this one has 1, 2 rows. What you now get is A, B, C.
What no
Eh?
Hey.
A, B, C, D. It is only when those two tables are the same. Eh?
Oh.
A and B. That is when you now have A. Hello. Great. Please help us smooth. Faraday, please mute. Please help us mute.
Hello? Hello?
Help us mute. Help us mute. That background noise is much. Thank you. So use this, but if it is ABAB, it will give you those 2 columns. But if it is ABBC, it will give you ABCD. That's the kind of join this guy is explaining for us. All right, so you can join, you can sort. So we'll try some of these things out. You can sort, so you can rename. You can sort index, you can reset index. So this is how to sort index. So let's say you want to sort from ascending order to descending order. You can sort values. You can see ascending is false. So ascending is false means you are sorting in descending order. So you say ascending is true, meaning you are sorting in descending order. But if it is false, meaning you are sorting in the other way around. So you can drop. This is the formula to, this is what you use to drop column. Maybe you want to drop 2 columns, right? You can drop columns. So you can also what? Subset. You can drop duplicates. This is how you can remove duplicate with Python. Remove duplicate rows. You can decide to say, okay, for example, you can decide to say, okay, I want to, in, what's it called? In Power Query, you can say I want to see the top 3, top 10. You can decide. So df.head is used to select the top 10. df.tail is used to select the down 10. Let's say the bottom 10. right? So this iLock is very important too. iLock is used to select a particular range of data. So if when I say iLock 10 to 20, this is going to return to me rows 10 to row 20. I just want to see rows 20. You will see that played out now. So you can see df width, length, and select multiple specific names. So I can decide to say, okay, I just want to see 3 columns. So if I have column 1, 2, 3, 4, 5, I can decide to I want to see two or 3 columns. I will mention the name of those columns I want to see, and it will give me the answer. Right? I can also use iLock. We'll see how that works. You can see you can use lock and iLock to get that. To summarize data, this is what you use. Maybe you want to do like in pivot table to know how many records you have. You can use the value count. You can use describe to see your statistics. You can see sum. There's also group by to group data, group by, aggregate functions. You want to group by pivot table. To drop NA. So this is how you undo missing data. You can either drop NAs and then, or you can fill NA with something. So anywhere you see blank, fill it with something. So these are these. You can make new columns. So let's say you want to add another new column. 2 ways. You can see this volume here is adding another new column, and the column, what forms that column is length times height times depth. So you can form another new column from another column. You can also compute and append one or more new columns. Okay, so this is also adding columns, right? So this is plotting. So Pandas also has a default plotting, which is df.plot, but it's not advanced. That's why we needed matplotlib and seaborn. So you can also combine data sets. So all those joins, you can do it here too. You can see this is ADF, this is BDF. So if I say pd.merge ADF to BDF, this is what I'm going to get. So you can see this is your type of, maybe is it left join, right join, inner join, or full join. So you can see. So in this case now, I'm merging ADF and BDF left join. So what does that mean? I mean, I'm mentioning on left and on X1. On X-man is, remember in SQL, when you want to join, you say select star or this one's from table 1, left join table 2, on S1 is equal to S2 from. So this is the same thing. So on is telling you the key you are using. How you want to join? Is it left join and then the 2 tables? You can see that it's returning all records there. Here you have ABC 1, 2, 3. Then you are now joining both together on S1. You know it's going to return S3. But now ABC is what is there. ABC is not here, so it will return null here, and which is what you have here. The kind of join. You can see if it is right join to return everything from ABD TFT, but for S2 it will not return C. So you have merge. These are joins, and basically that's all. So to test out what we've learned so far, and then of course, okay, let me see if that other part is there. Okay, you can see pivots. So keep this item very well, very, very key. It's not there, so no problem. So now we've imported our pandas, right? So I can create a data frame. So there, to create a data frame in pandas, right? So let's say I have a dictionary. So let me call let me just say DCT. So remember in dictionary, what you use is this kind of bracket, and then let's say I have names of students. So let me make this dictionary, this one, my header. Names. Names. might not really make it a dictionary. So far it's just headers. Names, you can make it a list, right? You can use a list. Remember list, we've gone through what we've done. Name, age, class. Those are the three things we want to. Now, those are my header. Now, my data itself is, so I want to input, let's say, 5 form of data now. So what will I do? So the first one, name, let's say, name, Michael, age, 10, class, class, class is SS2. So what I can do is I can put these ones inside a list. So names, 3 names, for example, Michael, Shegun, Shegun, and yeah. All right, this one will be in a list. Age as well, 10, 12, 15. That closes that list. All right, and then class, SS2, SS2, SS1, SS2, SS1, 3. I'll close that list as well. So we have 3 lists. Let's see any other lists. So we have 3 lists. This is a dictionary now, right? Now, Pandas has a function, right? So pd dot data. So pd dot data frame is a function used to turn a series of data into a into a table. So let me even print data. So you can see the way it's printing my data is just printing it on a normal, right? So, but there is a Pandas data frame will help us to convert this form, right, into a table, right? So I have model equals to pd data. Always please note the way, are you guys following? Know the way data frame is written, D capital, F capital. So I can now pass in what is my data frame I want to show data. What is the header? So before that, I think I need to show you guys something. PD data. So there's nothing in, but I can give you, so you can go to pandas.org to just check all these things so that it don't look abstract to you. But I know, I think in our data, in our sheet, there is a place where so I wanted to show us maybe there, okay, there was this place here where it wasn't a bar. So immediately I'll say pd.data frame. My data is what? There, so pd.data frame takes two major arguments. That's what I want to really tell us. It takes the data and maybe other things. Maybe you want to include index, column, and etc. But in this case, we don't want to include index, but want to include columns. So we say column is equal to, because we've defined our column before now to be what? Header. So columns equals to header. So we run this, it's successful, and then you can now say print. So what can you see now? You can see our data is now in the form of what? Hello? Are you guys there? Are you guys there? Hello? Hello? Ah.
Hello.
Ah. Okay.
Hello.
Are you guys with me?
We did. I did.
Okay.
This thing is getting complicated.
You know what? It's not what you just do is ensure you install. Have you installed this Jupyter notebook, and do you have all these libraries I just did?
I have PyCharm. It's only PyCharm I have.
But PyCharm is also okay. So all you need to do is just practice out. So I'm going to give us, I think, I'm going to give us, okay. I'm going to give us a website too, where we can also do some little practices of little things, so that like what I'm just doing now. And of course, this cheat sheet is also going to help us to do things. You can't know everything at once. That's why it's called cheat sheet, right? You just have it, and
Okay.
whenever you have any, okay, how do I do this? How do I do that? You can just come here and then you check. Even I could remember when I was going for data science interviews that time. I do have this on my hand. I'm checking in case. So when you are, so, and sometimes too, when you are going for interviews that maybe that requires you to write code, or maybe run good data. So what you can do in that case is, sometimes some guys will just, you have your code written somewhere, you just copy it, because you are repeating everything. So for example, maybe I'm using this kind of data in that interview. When they give me another set of data, all I just need to do is just what? Clean what is inside and just replace it with what they want. You get? So I won't be writing another, okay, PD import. Everything is already in my code. I will just be changing values inside, and I have my final answer.
But with this one now,
Okay.
with Power BI, like, what is the advancement in this? Like, so what is the major reason why
Okay.
you're
So why
making
we
use
use
of Python?
Python? Have you or Pandas?
Uh,
Okay, so the major reason is, there are some time you want to, okay, I think there was a time they gave you a data, right? The data was SAS data, and I cannot open it with Excel or even with my Power BI. So what I
okay.
did in that case was to first of all come here there is a way to read SAS data, SAS. I just said pd.read SAS and I pass in the file into Python, right? All I just need to do is after reading it, I just say pd.save to in Pandas as well, and I just save this as CSV. After saving it, immediately it will save to my folder, and from there I just pick it. I getting it now. So there are some times as well. For example, why you need this basically is if you want to do machine learning. You cannot, if you want to do your exploratory data analysis, you can't go and start because they want to see your skill in exploratory data analysis with Python. You want to make predictions now. They gave you a data of a loan company and you are to make predictions of those that will pay back their loan and all that. You can't just go and start from Excel to do the cleaning and then bring it. You can do that. You can clean your data in Power Query and everything. You just bring it here and say pd.read CSV or read Excel, right? And you bring it to Python and you continue with your predictions. But most times they will want to see your steps. Company want to see your steps. How did you think? They want to be sure you are using Python. So that's it. So it's not that. So and
Hello, sir.
yeah.
So all this you are saying now, are we going to do a practical example in this Python class, sir?
Yes, of course.
Okay, sir. Okay, sir.
You mean like a project?
Maybe a project before you now give us the final project.
Yeah. Okay. Yeah. I'll give you one.
A project that you draw on as a practical example to us before you now give us
A
the final
practical
project for us.
example, yeah, that you will see.
Yes.
Of course, now.
Yes.
I will do a prediction like maybe one or two.
Okay, sir. Oh, very good. Very good.
Machine learning prediction, yeah.
Oh, very good. Very good. Okay, sir.
So, yeah, myself. Okay, so did I answer your question, Drew? Sorry.
Odogu data.
Have I answered your question?
You've answered.
So,
Head of food.
we just have 6 minutes. So let's just have 6 minutes left.
Couple with boring.
So this is a dictionary. This is just an example of us converting a dictionary called data, and we use a Pandas function called data frame, right? pd.data frame, right? And we use it to convert. And pd.data frame takes many arguments, but the most important argument that it takes is the data itself, the index, if it has index, or columns. So the name of our columns are names, age, and class. So I've defined it before. I just need to call it columns is equal to header. And when I print it, you can see I have name, Mike, Shegunike, age, and then the class. So this is a way to turn a dictionary. So I can have as many data points, right? I can have maybe names, age, class. So meaning what we are doing, why we are doing this is let's say you have a company. So it's possible that you receive your data in form of JSON. So JSON, JavaScript object notation, is a form of a dictionary in Python. So you might need to convert that JSON document to a table and now import it. So this thing is all just like interwoven. You collected from a company web page a JSON file, right? From a JSON file, you bring it to Python because it will not look like this. To look like this, please. You now use pd.data frame to convert it to a table like what you are seeing here. And after converting to a table, you can now use pd dot to save. Use this one, and you now use it to convert it maybe to a CSV or Excel that you can access. And from there, you can now connect it again to Power BI. I get it now. From Power BI, you are now building your dashboard, right? And also, you can also connect your Python to SQL directly. So it's just seamless flow of data. So nothing really. So that's how you use the Pandas frame. But before we go, let me just introduce us to. So there are a lot of tools inside Pandas that you can use. I've just talked about pd.data frame. There's also something like pd dot. You've also seen pd dot to save files. Save files in different formats. But what I want to talk about is pd dot read CSV. Let me see, read Excel. This one will help us to read any Excel file. So let me quickly go to, I don't know if I have any Excel file. Let me go to my stuff. My drive, sorry guys. So I don't know why my drive, and I won't want to. Okay. Just want to download the sample itself. We just want us to load one Excel file. So basically, I just want us to load a file. Okay. So like this now, let me move it to download. All right. So I've moved it now. We have less than 1 minute. Should we do a bit of 20 minutes more to just round up this? We're fine. How fine with that?
Okay, sir.
Just to round it up. So I've moved that file now. Let me come back to Python. So first thing is there are commands that you cwd to get current working. Let's join with this same link, but we won't do more than 30 minutes. Or sometimes it's called pwd.